Well, thanks for coming. We're going to talk about a monitoring-based approach. If you are not interested in hearing about a monitoring-based approach project, you're in the wrong space, kind of like when you get on the wrong flight. I'm Greg Schlegel. This is Jane Geyer. You'll notice we're missing one person of our party here. Unfortunately, Sarah, our owner, ran into some red tape. She works for she works for the state of Utah, and I guess she didn't dot the I or cross the T in order to get her travel arrangements booked, and was not able to make it with us today. So we've talked with her extensively. We'll work on communicating her message the best we can. So apologies for that, but I think we've got a great presentation for you. A little bit about ETC Group, just to start off. We're an energy consulting company. We've been in business since 1988, so we're actually celebrating our 30th year. Jane and I are both with ETC Group. We're headquartered in Salt Lake City, Utah, and we have offices here in Las Vegas, Nevada, and in Tempe, Arizona. We're going to talk today about a monitoring-based commissioning project at the University of Utah. I'm going to talk about monitoring-based commissioning. I'm going to introduce it to you, describe what it is, why we do it, and Jane's going to then actually talk about the project where we applied it. So some of the learning objectives, I hope you're going to understand what a monitoring-based commissioning, what it is, what monitoring and analytics are. Get some perspective from a commissioning provider, where we've actually done it in the field, and also from an owner. And then we'll also give some tidbits of some of the challenges, benefits, some of the tools that we used, and hopefully we'll have some time at the end for questions and Q&A from everybody. So, what is monitoring-based commissioning? I went back to the 2009 monitoring-based commissioning study to get the definition. And monitoring-based commissioning is a measurement-based paradigm that affords improved risk management by identifying problems and opportunities that are missed with periodic commissioning or basic functional testing that do not incorporate energy measurement. Reminds me of reading a contract. So I like to simplify it a little bit, and I always think simpler is better. So monitoring, so looking at the data, getting the data stream, looking at it, continuously looking at the data. Add in the analytics. So the analytics are continuously analyzing that data, looking for issues, whether it be sensor issues, valve issues, scheduling issues. All this data comes out, the results of the analytics. Somebody needs to be looking at it, so we bring in the commissioning authority. They're looking at the results of the analytics, they're looking at the data. That's monitoring-based commissioning in a nutshell for me, something that I can understand. So why are we doing this? It's really important to understand a very real phenomenon in buildings, which is drift, right? There's our business as usual for a building. From day one, buildings drift, right? Schedules get overridden, equipment starts to fail, somebody gets a cold call in a building, they go and they adjust a set point, and then they get pulled off to go fix something. They forget about the set point that they adjusted, and it continues and continues, and the energy consumption of a building goes up. So we're doing monitoring-based commissioning to fight this drift. That orange bar right there, that's the value that we can provide over time in energy savings just by keeping a building at status quo. So we don't want status quo, we want to be better than status quo, right? So the first step is retrocommissioning. With retrocommissioning, you basically get this sawtooth wave going on, right? So we drop the energy use of a building, but then we encounter some drift, right? Drifts back up. 3 or 4 years later, we come back, retrocommission it again, drop the savings down, or increase the savings, drop the energy use down, but then it starts drifting back up. It's interesting, we've actually seen this on projects. We did a retrocommissioning project for a large healthcare facility down in Arizona. We dropped their energy use way down. 3 to 4 years later, we have to go back in. We saw the drift in the utility bills. It's a real phenomenon. So, getting better than that, we want to go after this next little chunk of savings right here in the green bar, and this is a monitoring-based commissioning gets you. So now we're able to drive energy use down and then keep it down by continuously looking at the performance, basically continuously commissioning the facility. So this avoids the drift, and you also get an additional benefit here, which we call the deeper dive. So the deeper dive allows you're getting at all this data, you're looking at how the buildings operate, you really understand, you're looking for these opportunities, and you can actually start driving the energy use of the building down. So instead of the building drifting and running away from you, with a monitoring-based approach, we're able to drive the energy use down. So that's why we're doing it. And can't forget about commissioning, right? So you start out business as usual, but you make sure you commission the building from the get-go. You commission the building from the get-go, you drive that whole thing down. So we want a high-performing building from the beginning, implement a monitoring-based commissioning approach into ongoing operations, and you can get a real high-performing facility out of that. So, kind of a high level, what is it? I'm not going to ask for a raise of hands of who's had an EKG before, but it's a really good analogy, I think. So with an EKG, you kind of start out, you're like, ooh, I've got something going on here. Call the doctor. He sends, hooks you up to an EKG. So you get all the little sensors. They put them all over your chest or whatever, and they plug you into the machine, and then maybe you have to you carry a portable one around, or you get a little temporary one, whatever's happening there. But that's your sensors, right? That's your sensors monitoring your system. Those sensors are collecting data over time, whether it's 5-minute data, 1-minute data, 15-minute data. I'm not really sure, but it's collecting data. Doctor comes in. He's the analytics, right? So he's looking at that to understand what's going on. Do you have a atrial fib? What do you got going on there? And then he tells you, all right, well, maybe you need to stop eating some bacon. Maybe you need to go get more exercise. Maybe you need to reduce your stress levels. Go play some more golf. And then you go take action, right? So wouldn't it be great if you could apply the same concept to your building? So it's the same concept, really, when it comes down to it. You've got all your hardware in your building. Meters, sensors, building automation system, production data. Maybe it's an industrial facility and you're looking at energy use per widget that's produced out of the industrial facility. Take some weather data. It's really important to not just take everything. Kind of identify what you're doing, think through what you're doing. Don't grab all the data if you don't need it. So if you're doing a high-level energy management type project, get the high-level data. If you're diving down deep, you may need to go out into the terminal units and get every terminal unit in the facility. One of the hardest parts about the whole process is this, data wrangling. How do you get the data out of the facility? This is where you're starting to run into firewalls. Where do you put the server? If you're in a healthcare facility, you might run into some HIPAA privacy issues. If you're working in the casino industry, they have really rigid firewalls. So you have to figure out how to get the data out of the facility into your system. And that system could be a cloud-based system. Then you have to get it out of the firewall. Some of the systems you can actually put inside the firewall and do a local instance. Now, once the data starts collecting, then you're collecting the data, you're storing the data in your system, and the analytics are running. So we're collecting this data every 15 minutes, and every 15 minutes these analytics are looking at your building operation, and they're looking for issues. And that's when the analytics start firing, and they find those issues, and you start getting a list of operational issues. Now, the communication is one of the critical components, I think. How do you take all this data, so suddenly we have all this data, a whole pile of analytical information and operational issues. We have to prioritize that and then communicate that to the people that actually do the fixing. And that's one of the other key aspects of the process, is getting the actionable information out of the data and out of the analytics into a facility management team so they can actually make the fixes. So, some of the benefits, sampling. Sampling can go away with a monitoring-based approach. You can go in and test all of the terminal, if you have 1,000 VAV boxes in a building, if you'd have to go and field test all that, it would take quite a bit of time. With a monitoring-based approach, you can use the data to inform your field work. One of the things we like to do is a 30-day observation. So in a functional testing process, we'll go in and functionally test all the equipment, make sure everything's working right, and then we'll have our analytics, and we'll be grabbing data for the first 30 days of operation to make sure everything's running really well through varying loads, varying occupancy as people are moving into the building. Using the system during the warranty period is really beneficial. We find lots of additional issues after the functional testing process is complete, the building's being burned in, being occupied. This is great value to the owner because we're finding all these issues. They're not and the general contractor is on the hook to fix the issues. They're not handing them over to the owner to deal with and his facility management staff, which they really don't like. And then we have this great amount of data, and this is really valuable to other trades, control contractors, T&B, GC likes to look at it too sometimes to kind of monitor where things are at. Some of the challenges that we run into, cost. It's more expensive than a typical commissioning approach. You have to be able to communicate that value to your owner to get them to understand why they should pay more. Data wrangling, I kind of hit on that. Root cause analysis, the analytics are only going to take you so far. It's going to kind of point you in the direction of where the issue is, but you still have to have a commissioning authority, an engineer, a good technician, a control contractor, somebody to get out there to find out, hey, what's the actual issue and make that fix happen. And then communication. You don't want to get overwhelmed with the data. These systems can create a ton of data. You've got to be able to take it in bite-sized increments, go get it fixed, take another bite. So that's kind of a high-level overview. I'm going to pass the stage over to Jane, and she's going to talk about our project.
So now we're going to talk about application. Greg gave us a really great rundown on what the philosophy of modernity-based commissioning is, and now we'll talk about application. So I'm going to talk you through a real project that we did at the University of Utah, and I've got lots of graphs to show you, which are really the way the construction team was able to resolve a lot of the issues that we identified during the commissioning process. So I'll kind of talk you through that story. The project is at the Chemistry Building. It's a multiple sectioned building. There's a north tower. It was a 4-story tower with laboratory sections in the middle of the building and offices surrounding the building. This section in the middle was just a single story. They called it the connector building. It had a couple of laboratories where professors were doing kind of high-end research, just kind of critical spaces. And in the south end were more student labs with more office areas. So the university selected this building as part of their commitment to the Better Buildings Challenge. They had brought an engineer on board to identify energy savings projects, and they targeted their highest energy use facilities. So they selected their chemistry building, some of their high intensity energy use laboratory areas. So they had a couple other buildings that followed on in their entire Better Buildings Challenge effort. So the philosophy of the project was to convert this building from a constant volume airflow building to a variable volume airflow, and you can all imagine that that would immediately mean energy savings. Building is about 267,000 square feet. The equipment was a bit interesting. Who's dealt with dual duct? Yay, okay, good. I don't have to explain it too much. It's old, right? So dual duct systems are not really common these days. I happen to kind of like them because you can basically pick, do I need cooling or do I need heating? And you don't have to pick both. But this building had 3 dual duct air handling units, 1 in each tower and then a small one in the connector building. And that dual duct system created a little bit of an interesting phenomena once we got into the commissioning process. 100% outside air. Entire facility, 100% outside air. So you can imagine every opportunity to peel a CFM out of a space means energy saving. So that was the focus by the design engineers. The fans in the air handlers, I don't think I'm lying that the air handlers were about as big as this room. Maybe lying just a little bit, but big. So the old fans were replaced by a fan wall system in each of the 3 air handlers. There were 94 student laboratories, 30 fume hoods, and then 267 mixing boxes. So we still had quite a variety of sort of like common spaces, if you will, to deal with in the commissioning process. And then I'm jumping ahead to the grand answer, which was this was an energy project, and the measured savings is $381,000 a year. So the university was really satisfied with the final result of the project. So I'm going to talk a little bit about roles because it's really the people on the project that make things happen and make it successful. The owner, Sarah Boll, she was the district manager for the sciences buildings for the University of Utah, and she was meant to be here with us speaking if it weren't for her red tape. The facility director was Jim Mueller. He was the guy that ran the chemistry building. He's a little bit of a mad scientist. He's Einstein hair, and he was a PhD in chemistry, and yet he sat on the construction team with us, and he was the one that was a liaison to the professors in the building so that we could have the installation of the controls retrofit run smoothly. Burns and McDonnell were the engineers. They were hired to do the energy efficiency design for the university through the Better Buildings project. And we had a really good working relationship with them through the process of the project. The laboratory systems were TSI controls. The building automation system was a Honeywell, and it was installed by Wasatch Controls, which is one of our local vendors. The commissioning agent was ETC Group. I was the project manager and engineer. I had another lead engineer who's brilliant, and she did most of the heavy lifting on the project and most of the interaction with the team. And we also have Brian Cook back there, who I'm going to pick on right now. Brian is our commissioning technician, commissioning authority, but he was our technician on this project who did all of our field work and all of our on-site testing and evaluation and identifying of issues in the field. So on that note, we're going to talk a lot about the software version, or the software piece of commissioning, not to dismiss the fact that functional field testing is really critically important, especially in spaces like this. So that was part of this project. I'm just not going to talk a lot about it. And then finally, the analytics platform that we use was SkySpark. So what's so great about analytics during commissioning? And I have three things that I like about analytics during commissioning, and I'll talk you through examples of each one of these. The first is data visualization, which sounds kind of shallow. You can see data and trends and what's so great about looking at data, but it's really compelling to get people to take action, and I'll show you some of those stories. Analytics, and Greg already talked about this, the software has intelligence that we have programmed into it, so we can use that analytics tool to look at the data as it's coming in, identify what's working properly and what isn't working properly in all of the HVAC systems. And the analytics run over time, any time frame you want to look at, from the very moment that piece of equipment was integrated into SkySpark, until today. Like, this project started in 2015, so we've got data on all this equipment back to 2015. So if you're looking at, the operator's looking at a piece of equipment saying, why is my chiller doing this year? Did it do this last year? He can actually page back 1 year and answer his question in 2 minutes. So there's a lot of power in that over time piece of it. And then across all devices, Greg talked about this already, there were 267 mixing boxes. We looked at every single one of them. And then savings measurements. This actually wasn't part of our scope as the commissioning provider for this project, but I'll show you some examples of how feeding data into SkySpark can give really great summaries of savings on a project. So, I'm not going to show you that yet. So the project got started. The laboratory controls vendor had installed the first set of laboratory controls, and you guys probably all know, if you've worked in labs, the laboratory controls that are supplying the air valves into the space, the fume hood valves out, general exhaust valves out, those are all controlled by a laboratory control, a little box on the wall in the lab, and it's kind of a self-contained algorithm. That controller then transmits its data into the building automation system, and the building automation system is really just kind of a pass-through of the data or a method for the controls guys on campus to see what's going on in that lab. But the controller on the wall is the thing that's really doing the work in the laboratory. So they installed their first laboratory controls. The vendor checked it out. He had his lead engineer check it out. The controls guy checked it out. Test and balance was done. And they're like, okay, this is ready for commissioning. And we're like, great, let's get this first one fleshed out, and then you can continue to deploy on the other multiple labs. So we integrated it into SkySpark, and we let it run we let data collect for a week. And then we looked at the data, And that's what we saw. Does anybody see anything wrong? So this is a day. We're looking at time series data, and I'm going to show you a bunch of graphs in this presentation. This is time series data, so this is one day. Each one of these increments is an hour. You guys in the back probably can't see that. So every hour is what we're seeing on the x-axis here, and then this is airflow on the y-axis. The blue line is the cold deck airflow, and the red line is the hot deck airflow. So this was the commissioned product, or this was the, not commissioned product, this was the laboratory control that was delivered to the owner. So we said, whoa, that's not right. So we took this to the laboratory controls installer, and they said, we checked that out all. We have the parameters installed according to what the engineer specified. They had all sorts of defenses about the controllers and the programming that they had installed, and we're like, well. And then we showed this to Jim Mueller, the crazy, the PhD guy that runs the building, and he goes, well, that's why it's breezy in there. So, oops, I jumped ahead. Oh, I jumped ahead a lot. Oops, I jumped ahead way too much. Hold on. Okay. So we took this data and we called a meeting with the engineer and with the laboratory controls vendor. They actually brought their manufacturing engineer. Well, we had a phone conference with them, but they got their manufacturing engineer on the line because he's the one that had actually programmed the labs. And we talked about this data, and he had all kinds of other questions. He's like, well, what's the exhaust flow doing? Oh, what's the temperature in the room? And because we're in a data analytics tool, we could show all of those points to him right there live. And he said, well, what did it do last week? And we could page back a week and show him exactly how it performed. So we could show him lots of other parameters about what that system was doing that allowed him to go reprogram his controller to perform properly. So he did just that. This day that we were looking at is December 21st. I'm sure that's what he wanted to be doing on December 21st of 2015. But he fixed it, and on December 24th, they deployed a new software in the laboratory controller, and you can see the results of that. So now all of a sudden, our hot deck airflow has gone to 0, and our cold deck airflow is stabilized, but it's at maximum CFM setting. So we once again had another meeting with them, and at this point they were saying, like, can we get a login to this thing? Because they don't have the same capabilities of looking at the performance of their equipment. So they went back to the drawing board, and then on January 17th, they deployed yet another program in that laboratory controller. And now you can see how the system is performing. Our hot deck airflow is still shut off, and the cold deck airflow is modulating slightly in response probably to occupancy, to nighttime load, and we're down at 300 CFM instead of 800 CFM. So imagine this was, this is just one lab that we're looking at, but there were 94 labs in the whole facility. So take that 500 CFM difference that we just saved in this lab and multiply that by 94, and it was really a giant improvement on the performance. So this is a big picture of the resolution that looking at this data allowed the construction team to come together and fix. That was what, had this building not been commissioned, this is what was delivered to the owner. Hot deck, cold deck, erratic behavior. And now they're operating down here where there's modulating flow to the laboratory spaces. So the next thing that we're concerned about in a lab is safety, and actually it's not the next thing, it's really the primary thing. But we visited that next, and you can see how we can add exhaust flow to this same graph and look at it on a time series basis and see that our exhaust flow is always above our supply flow. All of these labs needed to maintain a negative pressure, so we could verify that. And looking at the time series data, kind of the human brain likes to see it in that format. I'll show you the analytics version in a second. But when this project closed out, we could verify that the labs are all operating at a negative pressure. Oops, sorry. So then I'm going to fast forward 6 months ahead. The project closed out in January. 6 months later, we do a 6-month review because there's seasonal changes and you want to see how the equipment is operating once it's in a heating or cooling mode that it wasn't in when you originally commissioned it. And so what we found was that all of a sudden there's some conditions here where our exhaust flow is less than our supply flow. So something in this laboratory had gone out of whack. So these are the kind of things that we want to bring to the facility staff. And in this case, this building was still under warranty, which is another thing that we talk about, and the benefit of monitoring is these issues that are identified are still under warranty and the responsibility of the construction team. So that's a time series view, and then you say, well, that's just one lab. Is this happening in other laboratories in the building? And that's where we can use the analytics tool, the analytics piece of the monitoring platform, and that looks like this. So now this analytic, what we're actually looking at is, I don't know if you can read that, negative pressure lost. So in other words, when there's an indicator here in color, that's saying negative pressure in this laboratory was lost. So it's an unsafe space for students. The platform is looking at all 94 laboratories, and it's only presented the issue in 6. And we can see the time frame over which, like how prevalent is this negative pressure issue in each one of these labs. So we can take this information to the laboratory controls guy or the facility staff, and they can fix it. And then again, fast forwarding even further, this project closed out in the early to mid 2016, and the owner was so satisfied with the monitoring capability, both from a life safety standpoint, from assuring that temperatures in spaces were maintained for the sake of the quality research that was happening in the building, and for energy efficiency, that they continued to leave this data analytics tool running on the building. And once a month, we visited what are the key failures, what are things that need to be fixed. The next month, we would visit whether or not the things we talked about the month before were fixed, and you could actually see in the data, which is really satisfying. And so this is a 2-year fast forward to, again, negative pressure loss. It was something we rigorously looked at every month. And there's a couple little blips on here. This is 3 minutes, but you can see that the building had stabilized and they were consistently maintaining the lab pressurization that was required. So another thing that I want to share with you, this particular visual isn't from the chemistry building. This is from a neighboring building, actually the library on the same campus. And the library underwent a controls retrofit about the same time, later that year, than the chemistry building. And so because of this platform, we said to the university, we want to use SkySpark as the commissioning tool for the library as well. And so they said, absolutely. So one of the things that we convinced them to do at the library was install occupancy sensors to control HVAC in spaces just like we're in right now. So in the library, there were a number of training rooms and classrooms that were very intermittently occupied. And so we installed occupancy sensors, and then we would set the minimum airflow back to 0 when there was nobody in the space. So they kind of bought in. We estimated some savings. They went for it. And then this is the result, which I think is such a cool visual. Like each one of these bars is one of the spaces, and where it's colored, that's when it's occupied. So you can very visually see, well, this is Saturday and Sunday. This is about a 2-week time span. This is Saturday and Sunday. None of these spaces were occupied on Sunday. This is the weekend as well. And then during the week, like in the middle of the day, of course, students were in the spaces. But everywhere that's blank, there was energy savings to be had. So that's what we're kind of showing on this top graph. That's the airflow to the space. And in many situations, that airflow is 0 in all of those spaces. We do still maintain temperature in the space, so if someone does come in, it's not 85 degrees or 65 degrees. It's a comfortable temperature, but we're just not delivering ventilation air to the space based on occupancy sensor. So as a result of this activity, the university pretty much standardized occupancy sensor installations in large spaces across campus. So that's kind of become one of their standards as a result of the demonstration and measurement of this install. Oh, whoops, I went backwards. And then this is my final slide I want to share with you. We talked a little bit about measured energy savings, and I'll go through this a little bit quickly, but basically what you can show is the blue bars on this graph are baseline energy use. So before we even work in a building, we look at the historic electric use or gas use in that facility, and we create a regression model that basically can predict if they did nothing in the building, what would that energy use profile look like? And that's what you see in the blue bars. And then the red bars are actually energy measured at the meter. So the blue is a do nothing program, and the red is live measured at the meter. This is actually, I think this is from Harrah's right across the street. They did a controls retrofit in the chill water plant. And so there was an electric meter dedicated to the chill water plant. So we could pull that signal right in, and that's what you're seeing in those red bars. So on the shoulder seasons, they're getting lots of savings. Summertime, when they're at peak load, not quite as much savings. But the other visual is looking at kilowatt hours saved. And then finally, what's really great is kilowatt hours cumulative. And in this case, over a year, they were at 2 million kilowatt hours saved, just measured right from the meter. And this is pretty easy to do and really visual, and something you can share with any level of facility manager. Promotes continuation of energy efficiency projects when you see that kind of success. Oops, oh, I keep going the wrong way. And now I would like to turn it over to Sarah Boll, but she's not here. I felt a little bad about that, but Greg said I should leave it in there. So Sarah, Greg and I, do you want to join, or are we going to? I'll just turn it over to you. Greg and I talked to Sarah on the phone to kind of download her perspective, and I think that's the critical piece of this presentation is the owner's perspective. So she had compiled these slides before we even came, but we'll talk through them with you, and I'll let Greg start.
You have the clicker. All right, so we talked enough about Sarah not being here. These are her slides. We're going to kind of try to tag team this as best as we can. These are some of the benefits she saw from the monitoring-based commissioning approach that she's been involved in. And she's a real driver in the state of Utah of this. Specifically on the chemistry building, I mean, I think Jane hit this on the head really well, is the 100% equipment checkout. I mean, we were looking at all the mixing boxes, all the labs, and we didn't have a field team. We had Brian. You know, Brian was our field guy, and he wasn't looking at all of that equipment. We were looking at it based on the data. We found a lot of issues. I mean, we wouldn't have found the issues that we found without our analytics tool, monitoring and analytics tool. So, and she saw that, she's aware of that, and she saw that value. One of the, and she also likes the value that we're providing during the warranty period. You know, we identified those laboratories that were going negative, and we were able to push that responsibility onto the contractor instead of the facility management team taking this from the how many times does that happen? The DNC group passes a building that's kind of working over to the facility management group. I mean, I hear grumbling about it all the time. This really helps that from happening. It's a great tool for holding contractors accountable. Another story that when Sarah started up at the state, there was a school of dentistry that we were involved in as the commissioning provider. And the facility manager of that facility, kind of a side note here, but one of the strange things at the University of Utah is they don't let their facility managers have access to the controls. So that's all locked down by the control shop. And so this guy, his name was Joe. Joe couldn't see how his building was performing, and he couldn't get any of that from the control system. So, but on this project, we implemented a monitoring-based commissioning approach, and he was able to get access to that data. And there was one space in the facility that, we flagged, it had some temperature issues. And we were having a heck of a time getting the contractor back out during the warranty period to fix the issue. There was a fire pipe, a water line going through the building, through this particular space. The temperature in this space was dropping down to 30, 25 degrees in this particular space. Still couldn't get the control contractor out there. Took a screenshot of the data in SkySpark, sent it to the control contractor, they were out there the next morning. The last thing they wanted to do is be liable for a burst water pipe flooding a space. So that was a great way to get the contractor's attention. A picture of the data speaks pretty loudly.
Oh, so the next thing that Sarah wanted to talk about was like the ongoing effort of monitoring-based commissioning or monitoring and analytics in a facility. So in the chemistry building, as I mentioned, commissioning was closed, but they continued to monitor the building for monthly periods for the next year. And now the university is looking at deploying monitoring and analytics on the entire campus. So through those efforts and sort of those pilot kind of test facilities, they've seen the value and they want to deploy that on a larger scale. Time savings for technicians. We kind of had a funny incident. There was a guy on the chemistry building project. His name was George. And he was nearing retirement. He knew a ton about the building. He could fix anything. He was awesome. But he did not want to log into one more IT type thing. So monitoring was out of his realm. But a couple months after the commissioning was closed, there were some seasonal changes, and he was having trouble with this. There was a three-way valve on a heat recovery coil on the air handling unit. He was having all kind of trouble with it, and he's trying to get the controls contractor out there to fix it, and he didn't really know what was going on, but he went out and he reworked the pneumatic line to the valve, and he called us up because he knew that we could see exactly what was going on with that valve through our data. He knew. He didn't want to go look at it himself, but he called up April, and he said, April's our engineer, and he's like, oh, I'm having trouble with this valve. And so we logged in, and we could totally see the valve was cycling madly, and on December 3rd or whatever day George went out there and fixed it, it totally stabilized. So even though he was not willing to sign up for the login of the monitoring and analytics platform, he knew that information was out there, and I think those are the turning points that we like to see. We talked about reducing building drift. Sarah made mention of a USU facility called Holland Commons that came online about 3 years ago, and when it was commissioned, they were super psyched because the EUI was far lower than what they expected in the design. And then they set the building aside, and as energy manager for the state, she went and she reviewed all of the utility use for all of their major facilities and realized that this building had totally drifted up to 30% higher energy use over just 3 years. So some of those stories are convincing enough to create response using monitoring and analytics. Single monitoring platform. We didn't really talk about this too much, but on campuses, a lot of times there's a myriad of building automation systems, power meters, electric meters that are not really all on the same platform, but SkySpark can receive data from all of those systems. So energy managers can have one platform where they can see how their Siemens systems are operating, their Johnson Controls systems are operating, and a lot of times you'll have possibly have a chill water plant that's on one building automation system, and it's providing chill water to a building that has a different building automation system, but you can look at all of those data points in SkySpark at one time. And then facility managers visibility, and Greg kind of talked about that, and then the George story is pretty compelling.
Couple challenges that she wanted to bring up. She runs into control experts, right? They don't need another tool. They've got it. They've got it all figured out. And they almost feel threatened. You bring in a monitoring and analytics platform, they're experts at the control system. They're concerned about not being experts at the monitoring and analytics. And they're threatened. And you kind of have to be sensitive about getting them on board and showing them how it can make their life easier. An example would be looking at an air handler. Say you want to assess air handler performance, you've got an issue. Hopefully you've got trends set up in a control system. You get that trend data. Maybe you can look at it in the control system. More than likely you're taking that all down into an Excel spreadsheet, trying to line it up. It's about a 4-hour task. That is if you have trends set up. If you don't have trends set up, then you have to set up the trends, wait a week. You probably don't even have the data to troubleshoot the air handler issue. Monitoring and analytics, you could just log in about 5 minutes. You can troubleshoot what you're doing. A couple experiences like that, and you can win them over, but they are threatened. I mean, you have these control experts and these control gurus, and they're like, I don't need this. I can do everything in my building automation system. So that's one lesson learned. I think we talked a little bit about being overwhelmed with data. Making sure they understand how to prioritize, sort, sift, take small chunks. Cost. Yeah, there's definitely a cost. Sarah says she's seen the payback in 3 to 6 months. I mean, I kind of think that's a little aggressive, but that's what she told us. There's also a maintenance benefit, and that's kind of hard to track unless you're tying it into a CMMS system. So there's that benefit as well. And then the last point is, figuring out what approach is best for your facility. You might have a crack team inside your organization, and they can implement and deploy this internally. You may not. You want to bring in a third party. A lot of times we find out the best way to do this is some sort of combination of both. We're working with a large healthcare organization where we're coming in and helping them implement a program internally, training up their staff. Eventually we're going to work our way out of a job, but it helps accelerate their ability to adopt a monitoring-based commissioning approach. So with that, I think we have like a minute for questions. Maybe 2. Go ahead.
WebBased system, where's all the data being stored?
It's a pretty flexible system. So did everybody hear the question? He basically asked, is it a web-based system? You can do an on-premise, so you can install a server inside somebody's firewall. We also have a server up in the cloud, so you can, assuming you can get through the firewall and somebody will allow that connection, then it's web-based.
Can you test?
Can you speak to the integration piece at all?
In
How you take data from your EMS into SkySport?
that's the most challenging piece. And I'm not a technical expert on it, and we often run into issues. Open protocols are key, and the key factor is getting through the firewall. I think the systems, I'm trying to be non-proprietary as much as possible, but the systems that we have the biggest problems are Siemens, to be honest. I mean, Siemens Apogee, they lock it down pretty hard, and it's hard to tie into that. Anything BACnet IP, we're good to go. BACnet is pretty easy, we can tie in. So there's a number of different control systems that we've had good success. I mean, the University of Utah has Train, JCI, Johnson Controls, we've integrated to Honeywell. We've integrated to quite a few different building automation systems. I think the challenging part is when the commissioning provider needs to talk IT. That's when, and that's when I get over my head, and that's when I go, hey, I need some help here. And we do have some people on staff that can have those conversations, because you need to open up port 80 on your firewall and whatever that means. Does that help?
Yes, thank you.
Who did the integration? Was it your firm or SkySpark? Who did that?
We did the integration, yeah, so we have that capability in-house.
Did you guys have Haystack as part of the specification, or like as far as the naming convention? Because you can get into a ton of time if Haystack's not implemented. So how did you guys handle that?
We require it. So we in order for our analytics to work, we need to follow the Haystack tagging convention. So this was required on our projects. It's required, and the state of Utah. So if you'd ask Sarah, she's moving forward with a standard naming convention for all facilities, because part of the state's high performance building standard has a monitoring based requirement in it right now. So if any new building coming online for the state of Utah will have to have some type of monitoring and analytics platform, and there is a standard naming convention or tagging convention that she's working on.
Thank you.
Any other question? Okay.
Great. Well, thanks everybody. Appreciate your time, and enjoy the rest of your conference.